Welcome everyone to the workshop of RL4RealLife. This is our first Atlantic session on which specifically focuses on reinforcement learning for healthcare. And before introducing our speakers and the panelists, I'll give you a few technical details. So first of all, you should all be watching us on YouTube. If you have any questions, you can either place them on the general board on Slack or on the website. There's a link to some place where you can vote for all of the questions, and I'll forward them to Susan, who's our moderator. After this 1 hour panel, we'll have our virtual poster session, and also at the top of the website, you can find a link to spreadsheets with all of the posters we have, and also how to video conference into whoever is presenting the work. Okay, so those are the technical details. Let me now start by introducing our panelists. I'm super excited for this great panel. So first of all, we have Finale. Finale is a professor of computer science in Harvard. She's a Marshall and Sloan Fellow. She does a lot of work on machine learning for healthcare. In particularly, she focuses on reinforcement learning and interpretability. Next, we have Suchi. Suchi is a professor at Johns Hopkins University, a professor for computer science, statistics, and health policy. She won the Sloan Research Award, the DARPA Young Researcher Fellowship. She works a lot on many different aspects of machine learning for healthcare, in particular, many Bayesian methods, causality, and counterfactual reasoning methods. And the last speaker is Niranjani Prasad. Niranjani recently graduated from Princeton University, where she did her PhD with Barbara Engelhardt. She soon is going to be joining Microsoft Research at Cambridge in the healthcare unit. Niranjani did a lot of work on reinforcement learning for healthcare. In particular, one of her early works was on using reinforcement learning to learn when to wean people off mechanical ventilation. So during these days of Corona, his work has become super relevant again. And thanks again to our moderator, Susan Murphy. Susan is a professor for statistics and computer science in Harvard University. She won the 2013 MacArthur Award. She's a National Academy of Science Fellow and a National Academy of Medicine. She does quite a lot of work on mobile healthcare. In particular, I think she's a fantastic person to lead this panel, as she is one of the people who does the closest thing I know to an actual researcher who has RL applications which are actually used on real people and are starting to make a difference in the world. So yeah, Susan, I'll let you take it from here.
Yes, so it's great to be here with you guys. I particularly appreciate the questions that were put on that site for us. There are a couple of questions that were really near and dear to my heart. In fact, for some unknown reason, I didn't realize that Sushi was doing all this work in causal inference. It made me feel really good. So the first question, I don't know who posed this question, but the first question I want to pose to you guys is, it's from that list. It's how will, I'm going to list the question and then I'm going to ask it in two ways. And I just want to hear what you think. How will causality help the application of RL in healthcare? And in general, what is the relationship between RL and causality? And so if I would really like to hear your opinions. There's both off policy when you have a data set and you want to make causal inferences. And then there's also the idea of using causality in online RL. I would just like to hear what all of you guys have to say. I think it'd be really interesting. Who goes first?
You could go in alphabetical order.
Alphabetical order. Uh-oh. I'll go by first name.
Yeah.
Finale.
Absolutely. So I think in the off policy setting, I feel like there's stuff that causality can do for us, but I'm a little skeptical about it getting us to anything in real life, just because there are so many unmeasured confounds. And I think we're going to have to combine it with some form of perhaps expert knowledge about causality, which is why a lot of my work focuses on interpretability. I think a very exciting area, though, is in the on-policy setting, because that's the place where we can do efficient experimental design to actually figure out whether these things that we think are causal are actually causal or not. But I think, Suchi, you probably have many more opinions on, the limits of what can be done, especially from observational data.
But Sushi's not next because she's an S. Naranji is next. Can you go next, Naranji? Yeah.
Sure. I don't have too much more to add, because I have also primarily been thinking about the off policy setting. Though it'd be much more fun to obviously play with being able to run online experiments. And I feel like in the off policy evaluation, obviously there are a lot of direct parallels between the way we try to do multi-step policy evaluation and just A to B treatment decisions. And I would be excited to see how causal inference can help me decide, like in terms of like variable selection, because one of the things I worry about a lot is that some of the data that I am using are or some of the variables that I see are important in the policies that I learn are actually a result of clinicians already knowing, or the effect of, knowing the information that I'm pretending that I am presenting to them, or the patient state changing because of something the clinicians have done, not something that I am detecting, the machine learning algorithms detecting. So it'd be interesting to see if we can actually tease out but I do think my view has also been that domain knowledge is where I would turn to for this sort of thing. It seems a hard problem for causal inference to solve, but yes, I will let Suchi talk.
So, and Susan, please chime in actually, because I know this is a topic that's pretty dear to you too. So I actually think causal inference and reinforcement learning is kind of a bit of a Venn diagram with an overlap. So I think there's confusion in the community in terms of like, what is RL, what's causal inference, what causal inference can or can't do. So just before we talk about kind of details, at a super high level, I think we want to be able to take data collected in various settings in scenarios where maybe we didn't have the ability to control the data collection policy, and that's observational data. And we want to be able to do inference from it and ideally do it correctly. In other words, whatever we infer, we want to understand how it can support decision-making. So that's one big challenge, which is the challenge of trying to infer takeaways from data that we didn't have full control over and collecting data. And I feel in RL, we've attempted to do this in the off-policy world, but I feel like the literature in causal inference is much richer and much more thoughtful in terms of the number of scenarios and how domain knowledge is brought in and leveraged and exploited to be able to determine what can or can't be inferred. It's not always possible to infer anything just because you have data. Things are not always identifiable. So this notion of like what is or isn't identifiable given historical data or observational data is, to me, sort of an idea that's come into the computer science world from causal inference. From the RL side of the world, I think what RL's done for an extensive period of time is being able to learn from interaction and being able to control who you're interacting with and being able to learn from interaction. And when you can control who you're interacting with and you're learning from that interaction, the inference problem is a little bit simpler than the offline case because you have control. So there's less confounding. So that's good. on the other hand, and then there's overlap here in terms of experimental design, which is choosing, whom to interact with. And there's a number of ideas from active learning, from RL, from traditional stats where people are thinking about experimental design, and how all of those come together. So to summarize, to me, I feel the RL versus causal inference dichotomy I find not as useful. I kind of like thinking of it as we want to learn from various data sources. These data sources have varying amount of complexity attached to it, which is, various sources of confounding, things we know or don't know about the world. Therefore, we know what can or can't be reliably estimated. And then we have the ability to interact in some cases. And the ideal scenario is one where we can learn from the data we already have. And then ideally we build on it in order to be able to interact with the world. So we've started from so we've done work where we leverage machine learning to be able to estimate from observational data in very complex observational data using Bayesian approaches in some cases where you have limited data. And then in scenarios where you have doubt about the assumptions you've had to make in order to be able to do those estimations, you can now do active learning. And we've done that, and that's been really, really interesting with users to be able to do active learning in selective cases where we're unsure and seek input, and that allows you to now correct areas where you previously might have made assumptions but you were unsure. So I hope that answers the question to some extent. I mean, it was a very meaty, big question, but Susan, I'm actually curious to hear your thoughts.
Well, I like the fact that I appreciate the fact that you brought in active learning. It does seem to me that the theory of RL or the way of thinking of RL might actually even help you tell the health scientists what kind of data they can collect. So they might have enough, they might be able to in future say, collect different kinds of data in the emergency room, for example, but they won't know what it is because they don't understand RL. They may not know what it is, right? And if the RL community can help people understand, the clinical team understand what kind of data would help them do a better job, as well as the active learning, I think that's really interesting because that's online, right? As opposed to pre. But both the beginning and online, it would be really quite nice. I see we have Chaba here. How did Chaba get in our meeting? We've been Zoom bombed by Chaba.
I don't know what's going on. I just, Zoom is magic.
I was going to say, like, this iterative process seems the most realistic to me. It's also the one that we've taken up, or the way we think in our lab. I don't even know if like RL can tell us what variables are missing, but what I think is very reasonable or pragmatic is that RL can propose something that looks funny because like, and you can say that there's assumptions. It could be the assumptions fault, or maybe you just forgot something, right? Yeah. And then the clinicians are like, oh, this is what you were missing. And then you maybe collect that extra variable. I'm thinking also like Niranjani, we were chatting like earlier this term about like, okay, if you could wave your wand and like, what could you get? Like, you know, if something could magically appear for you. And you mentioned like state space, right? Like if you could measure some notion of state, which I think is absolutely the case, right? And so it's this game of trying to get some reasonable state representation, which I think is analogous to the thing that lets you control for the confounders that you need to control for in a causal setting.
One another thing that I think worth clarifying is I think the role of domain knowledge. So I feel like there's a lot of like confusion in the field about the role of domain knowledge, and people think, you know, when you want to do causal inference, you have to make assumptions. You have to be able to say, under this setting, this is true, or I assume this to be true about the world, therefore I can estimate this. And without it, it's not possible. So I think many people think domain knowledge is optional, like it's like a perk. Let me use domain knowledge because that would be cool. But my point is, you just can't do any kind of correct inference, and this is especially important in, you know, things, the kinds of things like in healthcare, which all of us do, or decision making, you know, in all sorts of other important applications like recruiting, you know, where there are consequences. You want to be able to guarantee or understand like how reliable your inference is, and so you need to be able to know when it is correct and not correct, and for that you absolutely need domain knowledge. So I think the optionality of domain knowledge should disappear. That concept.
This is great. Yeah. So I had another question. This is from me. I was listening to your talks, fantastic talks. I appreciate it. I learned a lot. I mean, I'm next to Finale and I learned, and I didn't realize very interesting things Finale was talking about. So both Finale and Naranji talked about forming rewards. And it seems to me in healthcare, this is really difficult. And I was wondering, Finale talked about some tree-based ideas to form rewards. And Naranji was talking about, I think, inverse RL. And I was wondering, is any of this related to, you know, there's an old literature in medical decision-making called preference elicitation. And that does have a sequential decision-making aspect to it. And can you connect that, what you're doing, maybe it isn't connected, but maybe it is, to this older, mature literature in medical decision-making on preference elicitation?
I think that what for example, the tree-based work that we did would be a precursor to a more formal preference elicitation scheme. So in that work, what we did is we used IRL to identify an interpretable reward structure of the form that, hey, it looks like current practice is trying to keep this variable in this range, this other variable in this range. Doesn't seem like you care about this other variable too much, you know, as long as it's generally above this other value. And we tried to create a simple version of a reward function that reflects what seems to be going on right now. Mm-hmm. And the idea there is that that's meant to be a first cut, because many times we found that if we try to jump straight into preference elicitation, mm-hmm. we might be able to do some elicitation on a specific variable, like what's the ideal blood pressure range that you're trying to target, and you can talk to people about under what circumstances would you can try to, but there's things that they're going to forget and we're going to forget, like, you know, maybe you can bring the blood pressure into range, but you throw off their oxygen or something like that. So our work is meant to be like, here's an overview, at least of the variables we can measure, of what it looks like you're trying to do. And then we can start a process of refining that to make it more specific.
Yeah, I feel that what I tried to do with inverse reinforcement learning was pretty coarse as well. So I guess I had talked about it in the setting of, this is sort of very recent. In the setting of trying to control something. In that case, it was like potassium, electrolyte levels, like potassium. And I was just trying to show that, from the data we see, their preferences, relative preferences of certain, avoiding too high levels versus too low levels are extremely imbalanced, or the relative preference of one mode of repletion versus another mode of repletion are very different, for example. And I'm not entirely familiar with the methodology. Like, I've always assumed they're all within the same sphere, preference elicitation, inverse RL and stuff. But yeah, I also recently, I'm sort of excited by, I've been looking at sort of like pneumonia data again, like returning to ventilation stuff. I'm kind of interested in how maybe we could, if we're using inverse reinforcement learning or preference elicitation, how we could see how these preferences are different across different subgroups. I feel like that's an interesting region. Again, it's just, you know, trying to do relative comparisons. It's really hard to make any concrete, conclusion from this.
Evaluability as well, because I didn't say that.
The evaluability stuff.
Yeah, because I think it's so important as a constraint.
Yes. So earlier, in my work with Finale, basically, we were trying to figure out, again, within the sort of the same, like assume rewards are linear in the state feature space sort of framework. We were looking at how we could sort of constrain the weights that we pose on that reward function. And I guess the two things that we felt were important were that they were somewhat reasonably close to the behavior. So this is sort of like, this is sort of like assuming you have an expert to an extent, or a suboptimal expert, and you're trying to restrict your behavior within some epsilon of that behavior, the expert's behavior. And the second constraint we posed was that we want to be able to get reasonably tight bounds on our performance, given the rewards we set for the policy we ultimately learn. And so the idea is basically that so that would basically end up, it's pretty similar. You want to have if you have pretty exploratory data that's covering your space pretty well, then maybe you could evaluate a much larger space of policies, and you can be more adventurous in what you sort of try to pose as possible optimal policies. So that was one direction we'd explored as well. There are several ways to approach this problem. I think that was one way we'd looked at it.
Have you all thought about using your work as like turning it into a prior? Does that make sense? Turning it into a prior for a preference solicitation, so you would guide it? Does that make sense?
Yeah. I maybe I should look at this literature more carefully. I have been trying to think about how that problem would actually work. But the idea is that this is sort of I guess current behavior is basically should be a prior on what the behavior we ultimately learn. But I haven't really figured out the best way of formalizing this yet. So any ideas you have?
Finale, do you want to say anything? Shaba's going to ask the next question after me, but I was thinking you might want to say something in response to this.
I actually, so maybe we can go to Chaba's question, which I think is related to what I was maybe going to.
Okay, Chaba, you're on.
Okay, sorry for the intrusion, but just this question occurred to me that recently I've been looking at whether multi-criteria and single criteria REL are how they are related, and then you think a little bit and then you figure that they are related, but there are some problems which cannot be really formulated as a single criteria problem, right? So the optimal behavior under a single criterion can never replicate the behavior under multiple criteria. And then the question is, okay, so if you're trying to identify the reward function that guides people's decision, like, should we really aim for a single criteria, or would it be more convenient to target this whole thing with a multi-criteria perspective in mind and go from there? So what do you think?
So
I think Naran, okay.
I've been thinking about this a lot. So I said I was setting the reward function as a weighted sum of state features, but what I actually did was using domain input. I formulate these multiple criteria first and try to figure out the relative weights that we would pose on them, because of course, all of these healthcare problems have multiple things that we're trying to optimize for, and it's really unclear. The main problem is we know what we want to happen in a high level, but we don't know how we should weight the relative importance of these. I tried looking at multi-objective. There's some work by Dan Lizotte a while ago about multi-objective FQI with like shorter horizons. And I've tried to think about how to, these would be extended to long horizons. It's, you have to make, again, additional assumptions to try not to actually get a deterministic policy, ultimately. Some more, hopefully domain-driven restrictions. But I think it's really important to figure out, definitely how to balance multiple criteria.
Yeah, because I found that clinicians really think in terms of outcomes, like multiple types of outcomes. Like we want to make sure that the patient stays conscious for example, or doesn't lose consciousness if they are in good shape now. We want to get the patient into this range for this value, that's which you can consider an outcome. We want them to be in this range for this other value, you can consider that an outcome. And recently, the way that we've been thinking about some of this is, maybe the right thing is to weight the multiple criteria, but other times it really seems like these are like feasible regions, right? Or it's kind of binary, that you're trying to get your agent into a feasible region or a nice region of a certain kind. And then maybe the thing you're trying to optimize might be something like, dosage. Like, you want to get them to a good region based on all these other outcomes with minimal dosage or in minimum time or something like that. So it's like a, minimize dosage with the constraint that, their blood pressure stays within this value or maximizes time within this value, and this and this and this. So, which you can turn into a weight, but it really is like, when you leave the bounds, it turns into something very bad. So in that sense, it does feel a bit more constraint-like.
The other thing I want people to think about, or I want to think about, is how, because these different criteria often operate over different time horizons.
Yeah.
So yeah, trying to control heart rate is like, oh, you only care about the next time step, and then it doesn't really affect what happens an hour later or whatever, several hours later. Whereas mortality or having to have the patient re-intubated and things like that are things that, yeah, whatever, present feedback over a long time. And yeah, I setting discount factors and stuff like that is in general, I don't know, pretty random for me. So a better way, I don't know, individualized discount factors for different criteria or something else. I'm not sure, but yeah, I would love ideas on that.
Suchi, did you have something you wanted to say?
No, I think this is good. I hear Li Hong wants to ask a follow-up question.
Oh, great.
Oh, hi. My question is that when you have multiple objectives, on one extreme, you could have a predefined preference vector to combine them into a single objective. That's the easy case. And on the other hand, you could also compute a whole Pareto front to give you to specify all the possible preference solutions. And my question is there a middle? Is there a solution between these two extremes that allows you to reason the trade-off, but doesn't require you to compute a whole frontier, which is very difficult to compute or represent?
I think clinicians are usually pretty good at providing at least like a partially ordered set. That some things are really important, some things are less important, and then you can start exploring from there. Another thing that's kind of tangential but maybe related is that some of the work in our lab, we've just tried to focus on finding diverse sets of policies that satisfy a single scalar reward criteria, but maybe perform differently on many other things. And this is like a way of providing a menu. So it's kind of doing it backwards, right? So instead of saying, let's do all the elicitation, it's saying that let's try to create a menu of ways that you could do the one, like this one task or reach this one goal that may have very different implications. And then we imagine there could be an iterative pruning process to try to figure out amongst those choices which might be preferable in what situation.
Shaba, can you make your comment, explain what you mean by Blackwell approachability?
Oh, yeah. So in multi-criteria, you can think about this Pareto optimality, or you could just think about that like homeostasis, like I need to approach this set with this criteria, right? And so Blackwell's approachability is the question of like, is there a policy such that this can be achieved, and how do we find policies to achieve this? So that's called Blackwell's approachability. I'm not that super familiar with it. I just know that Shai Manor, he was pushing multi-criteria RL for a long time by now. And this is one of the tools that he first looked at. So it's kind of like just a thought that maybe there is something there. I don't know what you guys know about it. Maybe know more than me. Yeah.
Oh, I appreciate it. I think now you've given us something, some homework, which is good for us. So Omar has given me a question and I'll read it. Okay, Omar? So this is a follow-up question to Li Hong's question. Just as Li Hong was right to point out that it's technically difficult to actually implement the multi-objective problems, do any of the panelists identify particular theoretical or algorithmic problems whose solution would be impactful for healthcare applications? I'm not quite sure exactly. I know of one. We know, for example, in mental illness that for a long time, psychiatrists have tried to do have clinical decision support. And there, what happens, it's very much in line with what I think some of what Finale does, is the clinician collects a lot of information from the patient, right in front, and they're entering it into the computer, and then the computer comes back with a whole list of options that might be possible. Change the medication, keep the person on the same medication, and so on. And the purpose of the clinical decision support system is to leave out the bad options. I think Finale may have mentioned this. So the whole RL problem is, what do you leave out, not what you put in. So it's like it's a different way, it's upside down. Finale, can you say anything about that?
I think this is like, in terms of RL for real life, I think this is a really important domain, right? Because like all we're talking about like multi-criteria, and I do think there's research questions in how to find those multiple solutions, because there might be multiple criteria, but unless multiple criteria result in multiple policies, it doesn't matter, right? So really we want a collection of policies that may be optimizing for multiple criteria. So I think that's an interesting question. To what extent, how much does this all just collapse on itself? And then how do you explain the policies well enough to a clinician so they may be able to say whether it matches your criteria or not? So there's that sort of research, but there's also this flip that you're talking about, because we find that there's almost a kind of hubris, right? To see, no matter how you set up your multi-criteria problem, that, oh yes, we're going to be able to quantify exactly what this patient needs. It's probably not going to be true. But if you can identify things that are bad ideas, that's probably very useful to prevent someone from making a careless mistake. And we've done some work in the psychiatry space with this, where we say that these drugs are probably going to cause severe enough side effects that the patient is not going to come back. Maybe you still prescribe those drugs, but now you do it knowing that, hey, I really need to take care of this potential adverse outcome before I go ahead and do this.
So I have a follow-up thought to what both of you just mentioned. So there was this paper that came out in, I think, Nature Medicine last year, which was on like an AI clinician or something like that to find optimal dosing for sepsis. And the thing was, they took, and I think a lot of there are many RL papers in healthcare applications that read like this to me. So they took longitudinal data and they split it and they binned it in some way and they turned it into a MDP and, finite horizon MDP. And then they sort of did optimization to identify in a given state what is the right dosing of pressors versus fluids. And so the problem, so just a little bit about the problem itself. The issue is people with sepsis have low blood pressure, and so the question is, in order to bring them blood pressure back up, or to tackle the fact that they're in this state, there's this lifelong debate that's been going on about should they be given more fluids or should they be given more pressors, or what's more effective, and kind of what the answer is unknown. Okay, so they tackled this as an MDP and search problem, and they came up with something. And so then there was a paper saying, look, AI clinician has solved all problems. Here it is. And to me, from having worked in the space now, having built, implemented, deployed, having seen many, having thousands of physicians use our tools on like now over 100,000 patients, realizing the complexity of how hard even very simple things are. When I was sort of thinking about that paper and like kind of, there are so many places, if you look back, there are holes. So first of all, the fact that even something as simple as taking longitudinal data and then just binning it, binning and discretization itself introduces bias, and if you're trying to estimate treatment effect, because the whole idea of being able to find the optimal policy relies on you being able to estimate the treatment effect. So in a given state, if you gave this dose of pressors versus fluids, what is the effect going to be? That is, what is the state change going to be?
So the binning was for the dosages? Because
the binning was for time. So they take state and they put heart rate in 4-hour time buckets and blood pressure in 4-hour time buckets. So they're saying, let me find buckets. I mean, and it's a thing very commonly people in RL do. It's a very common thing. So you take whatever measurements you've made within some period of time, and then you average it or do min max or whatever you want, create some version of a state. And then, they create this binning, and then that's your state representation. It's like a, fine thing to do. I mean, nearly 99.95% of papers do it. So they can't be blamed for doing something that is commonly done in the field. But they do this, and then they obviously their policy estimation relies on being able to then take this data, then estimate treatment effect from a given state, the effect of each, and then effect of pressors and fluids at a given dose. And I don't know if they binned fluids, but to me, the binning of fluids, they did. But I would say actually, so I think both of those would introduce bias in one form or another. And so, we wrote, it's done very commonly for all people who use MTP. So we sort of, implemented and showed a paper that actually binning has massive bias effects. And if you were to treat this in continuous time, you could remove this bias. But treating it in continuous time makes it a lot harder. By continuous time means as the measurements come in instead of binning. And the reason binning is bad is because it introduces confounding. This is a subtle argument for people who haven't thought about it before. But sort of in a nutshell, where I'm going with this is just really simple, commonly done approach. We declared victory on what I think is a very important, one example of a problem. And the challenge that I am seeing a lot when you start going from developing methodologies and implementing methodologies on paper to actually making it useful, we don't really have very many tools for critiquing these. Like, to me now, developing a method, testing, experimentally on some data set showing some performance, I see that as a 5% task. Like if I had to think about the level of estimate, I think of that as like, oh, that's straight. Yeah, let's do it. That's fun. It's deterministic. It's within our control. We know how to do it. Do it. And I think of that as like 5%. And then when you go from there to actually being able to say, is this going to actually work? Is this really going to work? Where is it going to fail? What's going to fail? To actually take it there, to me, in my experience, that's like 95%. And so how can we come up with, and as reviewers, when we're reviewing papers for these journals where these claims are being made, it's very hard because we don't have any tools to provide beyond very simple reporting of metrics of AUC or PPV or whatever. Like there's some super simple metrics people currently use, which are very gross and high level, which don't actually help you identify all the possible issues that can exist. So the real ask is, what are ways by which we can introduce ways to expedite this checking process? Like, can we come up with ways to new metrics, new evaluation criteria, new ways to probe, new ways to investigate a particular solution set so that we have faster ways to getting to something is working or not working? And to me in healthcare, a lot of machine learning applications are kind of landing there, because like people have now discovered they can write prediction papers, they can write policy optimization papers. So they just write it and they're like, boom, solved problem. But in reality, I'm saying that's fine. Like in my experience, majority of those fail and none of those work. So we really need ways, and that's like eroding faith in the field. Like people are, you know, sort of feeling like, okay, you know, they're not feeling as compelled to pick up a paper and then say, oh, this is going to actually work. So we need to like push the boundaries of being able to make more solid claims.
It's probably education that you need, right? Like educate people about the various pitfalls of following this methodology. And I imagine a flow chart, like, oh, you first check this, then check that, then check that. Like we have terminology for pretty much all of this, right? But people who are kind of new and they're super excited about this field and these applications might not be fully aware of these things. And why? Because it's hard to find these things. It's
Yeah,
like you have to.
So Omer and I had a commentary in Nature Medicine about kind of like a checklist, a very simplified, like if you all looked at it, you would think it's very simple, of like things that you should look at as a reader or as a consumer of these sorts of papers, so you can be appropriately skeptical. Because I think there's two issues, Suchi, that you're bringing up. Like one issue is that, you know, should there be papers like that are kind of like just RL application papers published in venues where like doctors are going to be reading them, and then their doctors are going to be sad because it doesn't make sense, or they look at something and then they're like, this whole RL business is a load of crap. And so there's that issue, right, of like how, like what can journal editors / you know, broader education do to solve that problem? And then I think there's another issue that you're bringing up, is just like, what do we do, right? Like, what is our checklist? What sort of sensitivity analyses should be running? What sort of causality checks and these sort of interpretability studies and all of these that we should be doing? And
I think I'm more interested in the latter. I think in the last year, there's been a slew of good articles helping educate the broader community in terms of checklists and protocols for reporting and evaluation. To me, that feels like that's one. What I'm more interested in us, like let's assume we're knowledgeable, we're very good at, you know, we understand the landscape, we understand the techniques, we understand the pitfalls. I'm saying, how can we accelerate research in shortcutting this validation process to be faster? Like, to me, it feels like as soon as we have that first, you know, on a data set, you can show your, you know, an example policy. Going from there to actually something that works is like art after that. Like you have to use your own sensibilities to determine how to probe the output. You have to use your own sensibilities to determine what kind of critique or input you're going to use to seek to identify holes. You're going to then figure out how are you going to actually then put heuristics or all sorts of other soft constraints to shape the solution to address where you were intending to actually go. And then do that in a very iterative fashion until you get to a happy place. And I'm saying that whole journey is 95% of work. And if we can figure out new tools, new ways, new, like, you know, emphasize research there, we could accelerate the whole field, right? We could all get to practical stuff that actually work faster.
Like, I think one great outcome maybe of this conversation is to create a list of many of the things that, you know, there might be, there's definitely going to be new things, right, that can accelerate the process. But there are things that kind of exist now that, as you say, like a lot of us in the field, we have picked up sensibilities of how to do this process, right? And we could create those checklists for fellow practitioners. I think that would be awesome. I think there is a question again of like, what bar does research have to hit for various types of outcomes, right? Because that path is, I think, is going to necessarily be somewhat long, because there's going to have to be iteration with experts. And, you know, if you really want to get all the way there, it's probably going to involve, as you were saying at the beginning, like maybe additional data collection of a certain kind. Maybe there's some holes that have to be filled. And so different people may not get all the way from like FQE or FQI on some data set to, you know, out in the real world. And the question is kind of, what are those stages?
Yeah, I think a big challenge that we haven't mentioned here is how the utility function of our PhD students and postdocs. Are they going to get credit for this kind of work? If they bring something to fruition, if they become embedded in a clinical team and they bring it to fruition where it actually gets put in a medical decision-making system, do they get credit? What kinds of papers do they write? Can they write? To me, that's part of the issue. It's very hard to get credit for a whole lot of those steps. And as a faculty member, I have to think of the best interests of my students and my postdocs, right? So what can y'all say? I think this is going to be the last thing we're going to be able potentially to talk about, but I would love to hear something about the education of postdocs and grad students if they want to go into this field. Can y'all give any comments on that? How about Sushi first? I'll go backwards.
Sure. I do agree with you, Susan, that it is like simply approached. This is a hard issue. And I definitely think there's just overall belief in the community that you don't get credit for this type of work. Yeah. But I actually think if you do it in a strategic way, then you can actually come out on the winning side by doing better work than you would have done by ignoring it. Mm-hmm. What I mean by this is, I actually think some of the most interesting problems I've discovered and some of my favorite papers I've written were all a result of actually pushing harder on thinking through what are the issues that come up as we try to actually, move the needle on this from a practical sense. And, it led to a slew of papers on thinking about safety, measuring reliability, learning methods that ensure safety and reliability or give guarantees around it, ways to measure things around data set shift that you want to protect against, ways to probe and, so I actually think personally, I think there's this myth that we can't get credit. And because the myth exists that we can't get credit, advisors don't encourage their students to be bold, and advisors themselves many times are not bold. And as a result, we all as a community do mediocre work when we put such a low bar for ourselves of saying we shouldn't do it because we can't get credit. That just doesn't seem reasonable. I think we should get rid of that myth, because if we try to actually get things to work, we'll discover hard problems along the way, because those are fraught with interesting issues, as opposed to simple criteria you might set up because you know how to solve it, versus some complicated setup you realize is requires more deep, elegant thinking. And then in the process, I think we'll have better papers. We're pushing our students to feel less constrained to live in an artificial world that isn't entirely reflective of it's hard. It always felt wrong to tell them, well, you got to optimize around an academic objective. Mm-hmm. And the academic objective is a little bit artificial. Anyway, so that's my thought. And I do think on the practical front, I feel there are many data examples from like my own advisor to other very good people in the field who I know who've taken this approach and have experienced tremendous success. And I would say even in my own experience, I felt that, like from sitting on hiring committees, evaluating papers, and my own personal experience of submitting to things that actually, I think when you're looking at the best rewards in academia, there are like very shiny rewards, including your own work. There you go. Your own work is an example of this, right? You've pushed the boundary in practical ways. And some of the best researchers, if you look at the people who get elected to the national academies, who win some of the better, big awards, they're all bold in this way. So I'm not sure that, I feel like that myth is not entirely true, and we ought to bust it. And I think it'll do us all good if we did.
Look, how about, this is great. Thank you, Sushi. This is great comments. I think we have a new PhD, someone who just came out who can really give us on the ground advice on how she saw it from her point of view. Can you tell us, Naranj?
Okay, I suppose, okay. I think, well, for one thing, I think it's important to have a big team and clinical collaborators and all present to be able to do that sort of, to be able to do both things. Otherwise, of course, if my objective had been, I really want to get this one thing implemented, it would have taken the entire 5 years. And now that I've graduated, like I think it's only now that I'm like, this is my focus now. That's just the way things have been for me. Now I am talking to a clinician every week, and this is where I want to focus, and I don't care that I'm not working on a new technical problem each year, because I can just think about how to get this one thing pushed forward and solve whatever I need to, because as we said, we need more data. I think, as much as, everybody's been doing amazing work on off-policy evaluation and things like that, I think we've discussed how, some sort of trial is the only way we can actually sort of start evaluating these things. And clinicians themselves aren't really sure about what their criteria is. So, trying to get in there and get something implemented in some sort of shadow mode is really important for me to be able to try to evaluate my stuff. And if it was up to me, I would, exactly. I would have continued thinking about ventilation weaning, not thought about other problems, with the idea of getting more papers. And admittedly, my preference has throughout been on solving problems anyway. I just had to do enough to get through a CS PhD. But yeah, I definitely felt conflicted, is what I have to admit. But please, I understand. I hope things are different.
So Finale is going to have our last word.
Okay. I think things become different as soon as you get a lab. When you're on your own, you can't, like, the tension is there. And I remember feeling the tension, like, as a postdoc. I want to echo what you said, Niranjani. I think the success comes from having a team of people who are so that we're working on the same problem, even on the same set of problems, right, on the same domain, so that each person can share the load of doing the grunt work that comes with, like, cleaning out the data set. New variables have been collected. Now they have to be incorporated. We have to have, there's a lot of those pieces. And if you can spread that load, that's really important. And then as soon as you try to do something and it fails, that's a great technical question. But probably the person who's going to be looking at that technical question now needs to, like, spin off a little bit and think about the theory for a little while, just like a typical pattern in my lab. And then they're going to bring the theory back. But, they need the freedom to be able to go think about the theory and publish that ICML or NeurIPS paper that is more focused on that theory that comes from the real question, right? A real technical question, but now has to be formalized and abstracted in appropriate ways. And then they can come back into the project. But you didn't leave the project behind because there was a large team of people or sufficient number of people that you could spread that load out. And while that person is perhaps thinking about some theory, another person is keeping up with the application, and you can spread it out. Because I think that if you just, again, like what you were saying, Niranjani, if you're one person, you want to get something implemented in the real world, I think you're going to be caught up in a lot of the details that are really important details, right? You got to cross your T's.
It'll be very hard to do. You actually need a team if you're going to do anything real. And the assumption is,
and then it doesn't feel so bold anymore, right? Because you don't feel like, oh, I'm doing something crazy, because you're also still publishing in traditional venues. You're doing all the things that the traditional success measures, but you're doing it in a way that also advances these very real world objectives.
Well, this is great. Well, Omar, I have to hand it back to you now.
Okay, thanks, Susan. Thanks to all the panelists. Too bad we're not live, so not everyone can clap for you. But just so you know, I've been also watching the chats on mostly the YouTube, and everything generated like a very lively discussion. So I'll thank you in the name of everyone there. And for everyone else, let's disperse and meet in the private chat rooms to discuss the posters and papers we have. And thank you to the panelists.
Thanks, everyone.
For organizing us.
Bye-bye.
Thank you.